Hello everyone, this is the other movie that we continue from the last movie of chapter 2, and the last slide of last movie we stopped by that slide. The slide is about relative frequency distribution and how to construct relative frequency distribution. Okay, so this is the formula this is not the formula, this is the calculations that we use in order to find relative frequency for this frequency distribution table. Okay, and remind you, we have say review up to now 2.4, and you have a side for homework. Okay, now suppose that we already done 5 steps. We have developed or we have constructed frequency distribution table, and sometimes data table is so when you want to present your result, data table with many numbers is like sometimes it's not easy for audience to get, because for example when you look at the table there are many numbers. So audience may be confused, especially the audience who maybe don't like numbers, or they are not good at numbers, not good at calculation. When they look at this table with a full of numbers, with many numbers, they feel like not good or not comfortable. That's why sometimes it depends on audience. When you make a presentation for showing your result, it depends on the audience. So what kinds of audience will attend your presentation result? Those one they like calculation, they like numbers, or those one they don't like calculation, don't like numbers. Okay, in order to make it easy, normally table with number will be not good for make a presentation, but graph or graphic maybe is better for make a presentation. Okay, so this this slide will use the other technique in order to present our result. Graphic presentation of quantitative data set. Okay, so maybe I just recall or remind you to the graphic that we use in order to present, in order to summarize, in order to conclude frequency table. That frequency table that we have by using a qualitative data set. Okay, we're using qualitative data set in order to construct frequency table. Again, a table sometimes full of numbers or many numbers that is not easy to read, and not easy to understand. So graphic is more easy for make a presentation. So remember that one, we have frequency table from using qualitative data set. We use bar chart, and there are 3 types of bar chart. We use pie chart at that time. Okay, so I hope that you still remember how to make bar chart. We have 3 types of bar chart, and we have pie chart. Okay, but now we have quantitative data set. When we have quantitative data set and we want to make frequency distribution table, we need to run 5 steps. When you already completed those 5 steps, table must be developed, but table must be coming. Okay, when table coming, and if you take this table to make a slide presentation, again maybe yes, audience feel not comfortable, because there are many numbers there. That's why in order to make audience more comfortable to attend your and enjoy your presentation, enjoy your showing, you need to convert this table into graphic. So now what kinds of graph that we use in order to present our result in terms of frequency distribution table? That we use a quantitative data set. Okay, so to take a quick look at a trends of quantitative data sets, the use of charts or graphs is more important. So we just look the trends, the movement or direction, something like this. Okay. Code 3 charts will help portray, display, show a frequency distribution graphically R. So code 3 charts will help us to display, to portray, to show our result in terms of frequency distribution table. Okay, 3. But why is it only 4? This is different color. This different color not included in our 3 here. 3. First one, histogram. Second one, frequency polygon. Third one, the cumulative frequency polygon. These 3 are the core charts that we use in order to present, in order to look our trends from our trends of our quantitative data set. Okay, so now we go into the first one, histogram. Suppose that in order to make histogram, unless you have frequency distribution table, if you don't have, you cannot make histogram. Okay, suppose that 5 steps already done, frequency distribution table already used or reconstructed, and then by using frequency distribution table that we just developed or constructed, we can convert it into histogram. So what is histogram? Histogram is a graph in which the classes are marked or are put on horizontal axis. You still remember? So what is horizontal axis? Horizontal axis is the axis that based on mathematics is OX. Okay, horizontal axis. So class that we study, we put on horizontal axis. Class frequencies, we put on vertical axis. What is vertical axis? Vertical axis is like here. Okay, up here, up and down. This is horizontal, maybe right to left to right or right to left. This is horizontal. But we're talking about vertical is bottom to up or up to bottom or down to up, up to down. This is a vertical axis. Okay, in order to draw histogram, you need to put class or groups or category that we study from our table on horizontal and class frequency on vertical. The class frequencies are represented by heights of the bars. Maybe you already got the point bars from we done from the first movie. Bar, the height, the tall of the bar, or the height of the bar, and the bars are drawn adjacent. What is adjacent? Adjacent to each other. Adjacent to each other, that means from one bar to next bar there is no space. Maybe you still remember from 3 bar chart that we draw or that we draw for the first movie, simple, cluster, and stacked bar chart. Those 3 bar chart, when you look at from one bar to the other bar, we have space. Okay, we have space. But for histogram, is special bar chart. Histogram is special bar chart. Why is it special? Yes, because they have a bars like a simple bar chart or stack bar chart or cluster bar chart. But special because of one class represent one bar and the other class represent the other bar. There is no distance, there is no gap, there is no space. They close to each other. They close, very close to each other. They overlap. One ending of the bar and the other ending of the bar overlap with each other. Okay. So that means from bar to next bar are drawn adjacent to each other. What does it mean? Drawn without any space. A histogram describes a frequency distribution using a series of adjacent rectangles, rectangle bar chart, where the height of each rectangle is proportional to the frequency class represents. Okay, so this is histogram. Suppose that we have new table, new data. I have this one, table 2.7, show male life expectancy from 40 countries. From 40 countries. So from 40 countries, this is data set. So n equal to 40. This is data set, not yet developed into frequency distribution table. That's why based on this one you need to run 5 steps. But suppose that 5 steps already done, you got this one, and the other step 6 steps already done, you got this one. So column 1 and column 2, 5 steps done. If you add one more column, this 6 steps, the way that you find a relative frequency. Okay, so from raw data like this one, you use 5 steps, you got column 1, column 2. What topic that we're talking about, or we study about male life expectancy. This is country, this is the year, numbers of year that one male in this country expect to live and die during his life, from 0 day was born up to the day that they are died. Okay, so this is number of year, not number of female. Not number of male. This is number of years that one male, or that the male were born in this country can live. For example, Afghanistan's male could expect to live 45 years, and then after 45 years they died. This is average only. Okay, and this is source at birth. So when one baby boy was born today in Afghanistan, this baby boy was born today expect to live 45 years in average. This is from UNSD. This number, this year, not this number. Okay. So up to 5 steps from this, we convert this data set into 5 by running 5 steps. We got that one. So what is here? This is life expectancy. What is here? This is about what we studied is countries. Life expectancy. This is countries. This is country. So based on this one, I can say that one country, because only frequency only one country, the male from this one country expect to live from 36 to 43. Maybe you ask me, some of you ask me, we have this number, but why this column start from 36 to 43, 43, 50, 50 to 57, 57, 64, 64, 71, 71, 78, something like this. Okay, if you do 5 steps, you can get that one. And remember that if you do 5 steps, and step 3, L1 must be 36. And what is I? Okay, you can say what is I? I must be 7. Number of years expect to live from the lower life, a short life and longer life. This should be short life, longer life, or a short life. It is short life, longer life, or the longer life in the older in longer or in short life. Okay, so there are one country, the male expect to live from this year to that year. There are 15 countries, the male expect to live from this year to that year. Okay, that's why 5 steps done, we got this table. This is life expectancy, number of years. This is a number of countries, because we're talking about country here, countries. When we're talking about the other six step, this is the 5-step done, 6-step coming, you got relative frequency. Okay, relative frequency. From frequency distribution table above here, we can construct histogram chart by scaling. First scaling, put number. By scaling the class frequency along vertical, okay, put the class number along vertical. Vertical means up and down. Would mean y-axis. Either class limits or class midpoint along horizontal x. Class limit or class midpoint. Sometimes we use class limit lower, higher. Sometimes we use class midpoint. It depends on, because we have, remember that we have histogram, frequency polygon, cumulative frequency polygon. These are the charts or graph. Some graph they use for horizontal, some graph they use lower limit and high limit together, but some graph they use only midpoint class. That's why we use this one. Okay, so from frequency distribution table above, we can construct histogram in terms of histogram. Histogram we use class limit, not class midpoint. Histogram by scaling, by putting frequency on vertical and class limits lower, higher on horizontal. That's why it's here. Okay, remember that one. This is important. Don't forget to design. Design that means a condense, make it shorter. Why make it shorter? You can see the gap is done here. This is from this one to that one 7 year, right? From this one to that one 7 year. 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 This one to that one 7 year. This is 7 year. This distance. How about this year? Why short? A short like this 136, because this is 0 year. This is 36. 7 year tend to be a little bit shorter than 36. It's not possible. It should be longer, because how from 0 to 36, how many 7? How many times for 7? 36, how many times? Almost 6 times. Okay, almost 6 times. That's why 1, 2, 3, 4, 5, 6. So 36 is start from this 0, 36 should be around here. But why 36 here? Because I use design. Why I need to make it longer? Because this is nothing. That's why I use make it shorter. So in order to make shorter, you can use design. Design is the mean shorten the area that not important. The shorten area, we shorten the area that not covering, not study. That's why. Okay. So this is 36 should be longer, like this one. This is 0, this is 36, and then 36 something continue from that one. But why I need to keep space nothing here? That's why I need to make it shorten. Okay, to design it, make it shorten. So based on this frequency distribution table, I can make like this one. From 36 to 43 is only 1. Okay, it's only 1. 43 to 50 is only there are only 5. 5 here. 2, 6, 8. 1, 5, 2, 6, 11, and 12. No, not 12. 15. Okay, 15. Okay. So frequency is done. How to make frequency? By using this table. First, you need to scale it. You need to scale two sides, two axes. Horizontal by using a group that we study. Okay. Class or group that we study. Vertical is frequency. Vertical is frequency. This is class or group we study. Class group we study about our example here about expect light frequency birth for male. Frequency. Okay, frequency. When you scale it, you see from this one to 7 years, the same size, 7 years. This is 2 to 4, to 6 to 8 to 10 to 12 to 14. You see the same size, same size, same size. Don't make it messy. What does it mean? Don't make it messy. Like 2 here, 4 like this one, 6 this one, 8 this one, 10 that one. Like sometimes longer, sometimes shorter, sometimes longer, shorter. Why it's longer, shorter? Because they have the same distance, the same number. That's why they must have the same distance, the same gap, the same gap from 1 to 1. Okay. So how to draw it? You just draw right rectangle. You know the beginning of the first class and in the first class. You draw based on the frequency. What high number? Number 1. Okay, put number 1. Number 2. Okay, number 5. Number 6. What's the difference between simple bar chart and histogram? You can see there's no space. From one bar to next bar, there is space. Simple bar chart. But from one bar to next bar, there's no space. This is histogram. Okay. So we done like here one. We can conclude like this one. The lowest light expectancy is about 36, and the highest is 87. This is a range. Okay, range from L1 to H, last class. 15 country light expectancy. This is a this is the most concentration, or the largest concentration. The most concentration. 15 country. There's only one country that is one. Sometimes you don't need to use this one, but if you prefer to use this one, the most and the least, the most and the least, and it could be J shape like this one. So J shape is not symmetric. Most data set tend to be clustered in the higher level, high number. You can see higher number compared with lower number. This is J shape. Sometimes opposite J shape. That side. If that side, this is J shape. So most in the biggest number, the most cluster in the bigger number. For the lower number, less concentration. This is more concentration. But in terms of inverse J shape, like this one, the most concentration in the smaller number, the less concentration in the larger number. But it's J shape. Okay. But this one you need to. Sometimes you don't. This one you don't need to mention. Just mention only 3 points here. You can see cluster. Actually, there's no cluster, but I can say this cluster from 57 to 78 is a cluster to each other, but it's not really cluster. Okay, but I can say it because we have lower here. Okay, back to our car price. Selling price of the car sold last month from Rob. We can construct this histogram. Again, don't forget this one. This is 0. This is 1 gap. This is 4. This range 4,490. Why this one 4? It should be not 26,000. This is $0. This is $23,000. Why is it only a small amount? It's 23. The same distance is 4,000. This is 23,000. Actually, it should be longer than this one, but I condensed it, or I make it short. Why? Because this is not important. Nothing here. That's why I make it shorter. Okay. So I draw beginning price for the first class, ending price of the first class. I draw number of cars sold. How many cars sold from this price? 10. How many cars sold from second rank price? Second class price is 21, 20, something like 15, 8, 4, or 2, something like this. That's why again, based on this one, I can say 19 to this is a range or coverage, and the most. Okay, most vehicles sold from this one, not including this one. The only few vehicles sold less price. This one, not less price, highest price. This one, more expensive price. There's a tail on the right. This is a tail. I will show you the tail. What is the tail? Actually, when you look at animal has a head. Animal has a head and also has a tail. This is a tail on the right. This is like a look animal side. Okay, there's a tail on the right side of the class with the highest frequency mode on the left, highest on the left. That's why this is animal side. So animal side, if our histogram shape or histogram graph is not symmetric, that means it's like animal side, it's not symmetric. What does it mean symmetric? This is symmetric. So common histogram shapes. According to the shapes of histograms, distribution can be classified as into 1. Symmetrical distribution, or 2. Skewness distribution. So what does it mean? A symmetrical distribution. Symmetrical distribution is one histogram shape in which if we divide its histogram into two parts or two pieces by drawing a vertical line through the center. This is vertical line through the center. This is center. The two halves form a mirror image of each other. Two half, one half and the other half. Because when we use a vertical drawing on the mirror, we like a split. We divided this histogram into two parts, the left part and the right part. The left part and the right part compare with the middle, before the central, they are the same shape or the same side. That's why the mirror image. When like this mirror, when you look at this one, you can see in the mirror the same thing as you. Okay, that's why this is we call symmetrical distribution. Any histogram shape become a symmetrical distribution if you split this histogram by the central point or by central area. You can get two parts. So one part is the same size as the other part. That's why this is called symmetrical. Sometimes we call symmetrical distribution as bell shape. Okay, this is bell. You know the bell? Okay, the bell. Bell we use in order to make sound. Like normally in our country, ice cream, selling ice cream. Okay, this is a bell. When I split by the bell on the middle, on the central part, I have two parts, the left side part and the right side part. Compared to this line, the left side part the same size as or the same features as the right side part. That's why this is we call symmetrical distribution, or sometimes we call bell shape. Okay, called bell shape. What if our histogram shape not bell shape? If our histogram shape not bell shape, it should be skewed distribution. In terms of skewed distribution, there are two: skew to the right or skew right, skew to the left or skew left. It is quite common to have one tail of distribution longer than the other. Actually, there are two tails. This is one tail, this is one tail. This is one tail, back to symmetrical. This is one tail, this is the two tail. So one tail, two tail, compared with the central, they are the same size. However, when two tails are not the same size, compared with center, like this center, they are not the same size. Okay, this one lower, this is higher. That's why this is not symmetric or not bell shape. If not symmetric or not bell shape, this histogram becomes skewed distribution. Okay, sometimes skewed to the right. This one, tail on the right, skewed to the left, tail on the left. Tail Normally, yes, we call, when we're talking about animal has one side a head and the other side is tail. Okay, let's say this one. This is a dog. Okay, you can see the shape is similar. This one. This is head on the dog. This is the tail on the dog. That's why the tail on the right. When you read this one, your hand, left hand side is there, right hand side is there. That's why the tail on the right hand side is skewed to the right. Our histogram shape is skewed to the right because tail on the right, head on the left. How about the other one? This one is skewed to the left because the tail on the left and the head on the right. Okay, that's why if our histogram shape is not bell shape, it should be animal shape or skewed shape. Skewed to the right, skewed to the left. Okay. Okay, so I finish this. Uh, this is the first movie for chapter 2 by this slide. Next, I will continue from this slide. Okay, so now these movies are for you to work.